Today you're doing a video on the SICK SLT, which is a IO-Link smart light, and how we can use it for liquid level height detection, as far as if it's 50%, 100%, or how much liquid level we have. SLT's fully configurable. I've already got this one configured. I'll kind of run through some of the settings. I can simulate the field level if I want. I'll be doing that with a PLC. On the color, I've already got it in field mode. All of this is user configurable as well. We've got 3 different modes: signal, lamp mode, filling mode, and animation mode. I'm just going to put it in field mode. So as the liquid level increases, I'll get out of my red into my warning and into my OK condition. So I've already got all this set up for what I want all the percentages to be. So now what I'll do is go ahead and close out of this, and we'll hook the SLT up to a PLC. Now I've already got this programmed and set up, but really wanted to go over how everything is mapped out so you would understand how to take that data and be able to where it lands at as far as the bits to determine what need to turn on to be at what percentage. So first what we'll do is we'll map out the network to understand where the data is. Right now I've got this plugged into port 1 of a SICK 350. And once I upload the network, it reaches out and it finds everything that I've got connected. On this network, I have a SICK 350 and a SICK 200. So I need to understand where that data is going. So my SICK 350 is starting for the inputs at D13,000, but the SLT is an IO-Link output. So I'm looking at D13,500 is where my data is going to start. So in looking at that, so I'm already on my output assembly. So what this does is this inside the SICK 350 itself to understand how the data is mapped across the PLC and where that's going to be coming from. So I can look here and I can understand what needs to turn on to be able to energize. Let me go to the SICK 350 since that's what it's on. So now I'm on the output assembly of the SICK 350. The other one was the SICK 200. It is a little bit different. So I can look at this and I know I'm starting at D13,500, which is what I have here. So once I start at D13,500, now I've got to look at which byte it's coming out of. So first, it says on the 4th byte, I have to energize that, activation of process data. So the 4th byte is going to be right 0, 1, 2, 3, 4. So the first bit of the 4th byte is where that data is going. Now the next byte, next 2 bytes is going to be my process data going to the SLT. And since I already have it in level mode, I know that I'm using 16 bits. And out of those 16 bits, that's how I'll map it over in those 2 bytes of data. And that is represented right here, IO-Link data, starting at byte 6. So byte 6 and 7 because I'm using 2 bytes of data according to the IODD file. So in looking at this, I can come back to my PLC program. Since I already have a program written in here, I'm not going to be able to force stuff on here. I will do it with the PLC program, however. So now I've got the program up, and we said we had to have it enable. So that's D13002, 13,502, which you see is on right now. So now we can come to 13,005 and start to turn things on. So there's 13,003.15, which is here. And this will start to turn on different alarms. I've got 3 different alarms set up. So if you watch here, we'll start to see these bits come on and off. And everything does something different. But if I want to actually get measurement data off of this, then the data is going to come here to these 7 bits. And all I have to do is turn on my program. And now as I run my hand up and down the SLT, you'll see that start to change. Or the up and down the CFP. And that's how it's mapped out.